Okay, I think we're ready to present our next speaker. His name is Jimmy Bogard, and he's a member of ASP Insiders Group, the C Insiders Group, and has received the Microsoft Most Valuable Professional Award every year since 2009. Jimmy is also the creator and maintainer of the popular OSCC libraries AutoMapper and MediatR. Jimmy is the chief architect at Headspring, a custom software consultancy based in Austin, Texas. Jimmy, the virtual stage is yours.
All right, thank you so much. You can also find me on Twitter at @jbogard. And this presentation, all the code on the slides, you can find on my GitHub at github.com/jbogard. There's a presentations repository there. And I blog a lot about this topic and others on my blog at jimmybogard.com. So the idea behind this talk has really come from a lot of experiences with clients who are new to domain-driven design and kind of approach it from this sort of utopian ideal that when they're going with domain-driven design, they need to start with a greenfield application and have like this perfect environment, this perfect atmosphere in order to create this perfect domain model. But in my experience doing domain-driven design over the last 10 or 15 years or so, is that kind of environment and perfection is almost impossible. And in fact, I'd say it's not even something we'd want to desire to get to. We don't really want to have this sort of perfect environment because the act of building a domain model can be a bit messy. And it takes a little bit of iteration with your code and with the business in order to achieve a well thought out and well working domain model. But before we get too far, let's go ahead and level set and talk about a few of these terms. So first of all, what is domain-driven design? Back there on my bookshelf, I've got the big blue book there. And inside of it never really precisely defines what domain-driven design is, as just the first part of the book is here's domain-driven design. So I kind of had to pull it out of there to be able to internalize myself. So for me, domain-driven design is an architectural design strategy in which we selectively distill, organize, and abstract the body of knowledge of the users into the software. And so the idea is that we're not trying to represent exactly reality. Like we're not trying to represent the real world down to like the quarks and atoms and stuff. Even the business itself, we're not trying to precisely model the business because business itself can be fairly messy as well. What we're trying to do is get the rough outline and the rough shape of that and distill it down to something that is still true to the real world, but is not a perfect representation of that. And so part of that domain-driven design work is to build an object model, a domain model that represents those concepts in the business. So that's the next part. So what is this domain model itself? And this idea of a domain model actually predates the domain-driven design book. I first encountered it in the Patterns of Enterprise Application Architecture book from Fowler, but it predates that as even well. So if you go back to OO design concepts and ideas, this idea of a domain model really originated way back then. And so from the Fowler book, it says that an object model of a domain is one that incorporates both behavior and data. And that's really the two key parts there. It's not just something that has the right names and the data in there, but also needs to incorporate the behavior as well. So it really needs to go beyond just sort of the nouns and attributes that we typically do in modeling sessions with our users in the business. It's really trying to incorporate the verbs in there as well, the behaviors of how these different objects interact with each other, as well as how they react to interactions with the end user. Okay, so we see this like, okay, great, let's do that. Let's go build one of these domain models. But for a lot of the code that I work with, it's not necessarily greenfield code where we're building it from scratch. We're working with existing code. So how do we work with the existing code, which, it sucks, right? Like the code that we have is always the code that sucks, and the code that we want is always the code that's great. So how do we move from the code that we have that we know that's maybe not the greatest code in the world to code that does really embody this concept of a domain model? And so when I was first starting out with domain-driven design, I was reading a lot of other kind of coding books at the time as well. And one of the books that really spoke to me were the ones around extreme programming and test-driven design. And test-driven design has this idea of RedGreen Refactor, where we write a failing test, then we have a passing test, and then the last step that most people ignore is to refactor. And in fact, I've seen a lot of TDD tutorials where the refactor step is not refactoring the code, it's refactoring the test. That's completely not the point of TDD. But if I'm working with legacy code, RedGreen Refactor means you have tests in the first place, or that you have the ability to write tests. But with legacy code, the code that sucks, usually it's like, can't do RedGreen because we don't even have a test suite, or our test suite is, I don't know, Bob over there, or Sally, who is the QA person who runs manual tests end to end. So we don't really have a test suite. So the only thing we really have going for us is the ability to refactor our existing code if we don't have the test suite underneath the covers to be able to back it up. So how do we accomplish this last step? How do we take existing maybe just ugly procedural big ball of mud code and refactor it into a clean domain model, which is the vast majority of situations that I run into? Well, these are not new ideas. These are not new concepts and new techniques. So what we can do is stand on the shoulders of giants, the people that came before us who really wrote down and documented all these kinds of techniques of how to take existing code and refactor it into nicely factored, clean code. So there's a few books out there that you can go out there and check out that really talk through a lot of the different problems of existing code and how do we refactor that code into good code. So some of the ones out there, the two major refactoring books, Refactoring from Valor and the Refactoring to Patterns, which is really looking at a larger perspective. But another one out there most people overlook is the Working Effectively with Legacy Code book from Michael Feathers. Now, while the other two are really talking about kind of cleaner code to begin with, Feathers' book is saying, well, what if you start with a big ball of mud? How do you refactor a big ball of mud into something else that is not legacy code anymore, which for him is code that can be tested? So what I wanted to do with today's presentation is start from a point of kind of a highly coupled procedural code where I've got like data access and web services and API calls all mixed together with business logic, and look at how can we use these kind of standard refactoring techniques and our tools to help us move from a place of a coupled big ball of mud into an actual domain model, which is fully encapsulated. So I want to talk a little bit about our domain model and what the current state is, because sometimes I do find that the data models of applications aren't too bad. That is, they got a lot of the nouns right. And so this application is one that I modeled after I worked with a few years back, which is one that was around building loyalty reward systems. And the idea behind these loyalty reward systems is to have just the people in the world, but those aren't the people we're really worried about. We're really worried about the people that decide to become members of this loyalty club. And I'm probably a member of, I don't know, a dozen or so of these things through airlines and hotels and things like that, where if I spend money and buy things from them, they'll give me points they could use to do coupons and discounts in the future. So in this case, this is our current domain model, although I wouldn't call this a domain model because it doesn't have any behavior. So this thing, I have a member that has the information about that member, and then it has a collection of assigned offers. So these are the offers that are assigned to a specific member. Now each offer has a kind of offer type that says, what are the kind of properties or attributes of this specific offer? So the idea is that I, as an administrator, can define different kinds of offers in my application, and then I assign those offers, and those become kind of like instances of that offer assigned to an individual member. Now, when I show this picture to the business, there's nothing that they disagree with here. Like, we're all using the same words, we're all using the same names of things, even the associations to things, they say yes. So if I want to talk about the offers for a member, those are the assigned offers. So even the names of those associations make sense to the business. So if I put this picture up to the business, they see it, and there's nothing they disagree with. Yeah, but this looks, we agree with all these names. So we're kind of ticking that first box of domain-driven design of having the ubiquitous language where the developers are using the same words as the business, and those words we're using make their way into the actual software. But there's a problem here. You notice that these types, these classes, only have data associated with them. There's no methods. So in this domain model, I only have the data, but where's the behavior? So the behavior does exist somewhere in my application, like something is setting values on these objects, something is mutating them. And so that behavioral code in my system is usually on the outside of the domain model, the outside of the application. And so depending on what kind of application I have, that can be in different places. So it could be in the controllers if I'm doing a kind of a web application. It can be in like event handling code if I'm doing more of a kind of a thick client, or even like a spa kind of application. I've also seen people take that code out of the controllers and kind of move it into something else. And that something else can be services or helpers or managers. It's all these names of classes that don't really describe the behaviors or the responsibilities or roles of the objects themselves. It's kind of just a bucket where we just take the code that was over here, just pull it out and put it in this other place over here. But it's not really improving the maintainability of the code. You just took it out of one place and stuck it to another. It's not unlike growing up when my mom told me to clean my room. I just take all the stuff on the floor and kind of shove it under the bed. You didn't actually solve the problem, just kind of hit it. So that's typically where I see a lot of applications when they do their like refactoring. It's just kind of shoving things under the rug, shoving things under the bed, but that problem is still there. Like the mess is still there, just kind of hidden out of view a little bit. But if I need to go change that code or be able to extend it, the mess is still there. It's still difficult to understand. It's still difficult to reason with. And if we were to take that code and try to refactor it, then perhaps we could have a better end spot. So let me go switch over to code. And the rest of this presentation, we're just going to be live refactoring actual real code. Okay, so in this application, you can imagine this being just like a web application or something like that. And what I've got is a set of code that is the code that represents the kind of one of the more important operations in this kind of domain model, which is assigning an offer to a user. And so I've refactored this code initially outside of the controller and stuck it in this case in a handler for, in this case, I'm using a mediator pattern to just basically take all the code out of the controller that's the real meat of it and shove it in here. So this code is doing a lot of stuff. It's kind of mixing a lot of different concerns together and a lot of different objects in order to accomplish the final goal of assigning an offer to a member. So let's go ahead and kind of dig into this step by step. So the first thing we have to do is do some data access. This is almost like every single kind of main block of logic I see in applications. And the first thing you do, you have to go get the data out of the database. That's typically the first thing that you have to do. In this case, the next thing I need to do is call an API to calculate the offer value. So in this case, the thing that calculates how much I want to assign this offer to this member, what is the value of that offer? They've extracted into another microservice that I can call via an API. So I call this API, I tell them that here's the member's email and the offer type, and it will tell me back the value of that offer. So this case is going to be a number. There's like the dollar value or monetary value of that offer. So once I call that API and get the value of the offer, the next thing I need to do is then calculate the expiration date. And this one's a little complicated in that it depends on the expiration type of the offer type. And the idea is that there are two main kinds of expiration types. One is one that that expires based on a sliding expiration. So you basically say this offer is good for 30 days or 15 days or 90 days, whatever it is. So starting from today, add those number of days, and then that is when that offer is going to expire. The second one is going to be a fixed date. The idea here is that it's if you have some very well-defined time window on the calendar, and you say like this offer is good until Saturday for everybody to get this offer, no matter when they try to claim the offer is good until a Saturday or Monday or whatever it might be. So in that case, what we'll do is we'll say take the number of days valid, say here's the offer's begin date, and the date expiration is going to be just adding from the begin date of the offer until the number of days that is valid. Okay, so once I have the value and when it expires, then it can actually assign the offer to the member. So the last part is just kind of doing the OO stuff, the entity framework stuff, is saying, okay, we have to create the offer object, We have to add the assigned offers to the member. We have to do a little bit of a data cleanup, in that in this case, we're displaying the number of active offers to the end user. And so we're pre-calculating that and storing it on the domain model itself and in the database to display the end user. And then the last thing we have to do is actually save the junk in the database. So looking at all this, it's like not the worst code in the world, right? Like I could probably come in here and modify it in the future, but if any one of these steps becomes more complicated, this is going to become much more difficult to maintain. So you can kind of see a lot of my handlers, a lot of my control flow looks exactly like this. Load up stuff from the database, load up stuff from external sources potentially, do some logic, and then save the junk to the database. And if this becomes complicated, I see what a lot of folks do is they start to do this. They start to add little code comments in there to say, this block of code does this. This block of code does that. And this block of code does this other thing. So they're using code comments as a way to kind of provide breadcrumbs to the next developer to say, here's what this next block of code does. So the very first refactoring we want to do is really the first refactoring I take on any complicated method. And this is known as the compose method refactoring. And the idea here is that if I have a big block of complex stuff, then what I want to do is break each of those different sections up in the code into a method that represents the same kind of conceptual level of abstraction or encapsulation. And I've already kind of done this with these code comments, like here's the first part of stuff, here's the second part of stuff, here's the third part of stuff. And I also kind of imagine as sort of a table of contents of code that I am describing. Here are the chapters, here are the sections, and I want to go read into the details, then I go to the method body to go see the rest. Now, the difference in the compose method refactoring is that I don't leave any part of the method unrefactored into a method. I refactor all the sections into individual methods, so the method reads kind of like I'm reading a table of contents. So now in this case, I'm using Visual Studio, the latest version that was released like what, yesterday? The 2019 whatever latest version. I'm also using another productivity tool, ReSharper from JetBrains. And the reason I'm using JetBrains ReSharper is because it's very, very powerful in terms of its refactoring capabilities. And a lot of the things that we'll be showing today are not actually possible with any other add-ins, free add-ins from any like vanilla Visual Studio or any other free add-ins. So I'm not getting any money from this from JetBrains. I've used ReSharper for forever. And so it's kind of just second nature for me. So in order for us to first kind of refactor these methods, I'll highlight the block of code I want to refactor, and then I'm going to tell it to extract a method. So in this case, I've got this set of code. I'm going to say extract a method, and I'm going to have to give it a name. I'm going to give it a name of calculate offer value. Now, how do I know what to call this method? Well, actually, I'm just looking at the code comment that I saw earlier, and that'll be the name of the new method. I can also move some of the method parameters down. I don't like the cancellation token first, so we'll move that last. And there we go. So now we have var value equals await calculate offer value. I'll do that same exact refactoring for the other ones. Now, I am up on the latest version of Visual Studio and the latest version of C#. And so I already see that there's some other refactorings I can do here in the meantime. So one of the things I can do here, this is an old case statement that includes this like case and break stuff. That's kind of ugly. So we refactor this into the latest and greatest switch expression. And the switch expression like removes a lot of the noise of all that stuff and really gets it down to kind of the base, the very, very kind of lowest common denominator of this switch expression. So the idea here is that I'm assigning this expression type, switching based on its value, saying if it's an assignment, do this calculation. If it's fixed, do this other calculation. And finally, the last one is to throw an exception. Now, you could say, let's go ahead and stop here because now I've got it to one statement. But I still like to extract this into its own individual method, even though it's one statement, just so everything kind of reads as one thing after another. So let's go ahead and refactor this into a method, and we will call it calculate expiration date. There we go. And the last thing is to assign an offer. So I'll highlight the code, say refactor this, and say assign offer. Okay. So at this point, I still could also extract these other two parts as methods, but I tend to leave the data access stuff alone because it's a little bit annoying to have multiple things coming out of these methods. So right now, I can look at this method. It does at this point, it does read very nicely. And so at this point, for a good percentage of my refactorings, when I'm looking at complicated code, I usually just stop right here, saying this is good enough. I have captured the overall steps that are going on. I've really removed the need for these comments because now I have self-documenting code. The methods describe exactly what's going on here. And so for this, for a lot of the code I work with, I say this is probably okay. We could probably just stop right here. However, let's go further. Because what we're trying to do here is build a behavioral domain model. I haven't done anything here except just kind of move code around and clean it up inside this one class, but I haven't actually made my domain model behavioral whatsoever. So let's do that as our next step. Let's see if we can take one of these methods and try to make it more behavioral. So I'm going to look at the calculate offer value method. Now this one does a few things. It's really calling this API, having to pass in some values, and then get the result back and return it as a number. Now, if I wanted to test this overall class, I would have to mock out this web service, this HTTP client. Instead of calling the real API, I call this fake API, whatever. But that's a little bit annoying to test. So it would be nice if I want to test this overall set of functionality. It would be nice to encapsulate the calling of this web service into its own individual class. So that's what I'd like to do next. But I want to do something first real quick. This right here is using a dependency, this HTTP client dependency. So if I were to refactor this into a separate class, it would have to be able to get that HTTP client thing somehow. So to make it easier myself to refactor, I like these methods to be static first. And they're static so that everything that it needs is actually passed in through a method parameter. So let's do that here. I'm going to refactor this HTTP client. I'm going to say introduce a parameter. And the HTTP client is now going to be passed in through a parameter as opposed to passed in via the field there. And so at this point, I can actually make this method static. And it'll make now this method much easier to extract out into a class. So let's do that now. I'm going to extract a class for this method. And let's call this method the offer value calculator. So what I'm doing is using the name of the method, which is a kind of verb base, and then using that and flipping around saying this is the role that this class is going to take. So the last thing we need to do is make this public so they can actually be called. And then down here, offer value.calculate offer value. Now this didn't make it actually easier to mock out. It didn't actually make it easier to mock out because we still have this HTTP client dependency. So what I'm gonna do next is transform this static method into an actual instance class and use HTTP client as the thing we pass into the other. So we're first going to extract an interface here. Oh, one thing real quick. I'm going to create a constructor here. And there may be a way to do this with the tools, but I haven't found one yet. But I'm going to, instead of having the HTTP client passed in as a method argument, I'm going to have the HTTP client passed in via a constructor argument. And the idea there is that I will have dependency injection, filled all the dependencies for this, like it's already doing for my code down here. So down here, instead of passing in HTTP clients, I'm going to be passing in an offer value calculator. Offer value calculator. And I no longer have that HTTP clients anymore. I'm going to be using the offer value calculator. And down here, instead of the static method, I'm going to be using an instance method and get rid of that HTTP client parameter. Okay, now I've got something injected. However, it's the concrete type, not the interface type. So the next thing I want to do is transform this into an interface that I can use to be able to inject the interface as opposed to the concrete class. So I'm going to extract an interface for this method, calculate offer value, and there we go. Now I have an I offer value calculator with that method that I have there. Here's the implementation of that interface with the dependency for HTTP clients. And now down here, I can tell it to use the base type wherever possible, because right now it's using the concrete type. But what I'd like to do is say, don't use the concrete type, depend on this interface so that I can give you a fake version of that in a unit test. So use the base type where possible. So it transformed the method parameter to an interface here, and now this is using the interface-based version of that. So just to sum up what I did there, I extracted the method. I converted it to a static method to ensure that all the things it was using was getting passed in through the method parameters. Then I extracted a class for that method over here. And then finally, I extracted an interface for that, transforming all of the dependencies into constructor parameters so that I can inject this in the actual runtime application. It gets injected with the correct dependencies. So at this point, I feel like that part is fully encapsulated and also kind of separated out from the rest of the real business logic of my application. All right, so let's look at the next method here. Calculate expiration date. Now looking at this doesn't look bad, right? I've kind of whittled it down to a single switch expression using this new switch expression logic. Now, if it was just this one place in my system that looked like this, I could say, okay, that's good enough. Like, no need to do anything else. But if I start to notice that these switches start to become more and more prevalent, then I may want to do something about it. But the first thing let's do is look at this method and say, does this method, can I move this method somewhere else where it's more likely to belong? So in this case, I've got this method, calculate expiration date, that is dealing with offer type. And inside of this method, it's not accessing any dependencies, right? Because it's static, so it's not talking to the base dependencies. And it's only dealing with this offer type object. So this is a code smell. This is known as inappropriate intimacy, in which I have one set of code really up in the business of another object over here. And so what I can do is move this method from this object over to this other object. To say, really, if this code is really just dealing with this one object, then let's go ahead and move it to that other type. So let's do that. Move to another type. And what type should we move it to? We're going to move it to this offer type object. Offer type. Next. Access rights will be extended. Sure. Okay. So over here, we've got date expiring, offer type, calculated expiration dates, but it made it static. That's not exactly what I want to do. So let's actually back this out one step and make it back over here with a static method. There's another really cool refactoring here, which is make method non-static. And when you make a method non-static, you look at the instance parameters and say, what instance parameter can we transform and make this method going from a static into an instance method on that object? So when I do this, it actually says, which instance parameter do you want to use as the target for this method? So I say the offer type method or the offer type object. So now up here, we can look at, instead of having a static method on that object, it's now an instance method, offer type.calculate expiration date. So now my offer type object, I've got that switch expression over here that says date expiring, but now look, it's using, instead of going into the dotting into that object, it's transformed all the cases that it used offer type into just accessing the instant properties itself. Pretty cool refactoring. Okay, so the next thing I'm looking at is the switch expression. Now, it's using, in this case, it's using an enum, which are fine in .NET, but enums are really just kind of, they're fancy numbers. They're ints with benefits. Because if you look at an expiration type, it really is underneath the covers just a number. So if I go expiration type foo, I can give it 1 or 0 or 20. And although the compiler may not let me do this at runtime, I could actually have these values be associated with this number, with this enum, because underneath the covers, it is still just a numeric value that's wrapped in some kind of nice behavior. But one of the problems with enums in .NET is they can only be data. You cannot have behavior associated with them. So I can't move this kind of logic of calculating the expiration date over to that enum object, because we can't have methods on enums. Maybe someday that'll change, but you can't do that today. So this is known as a primitive absorption, where I've got a lot of code dealing with this primitive, in this case an enum, but the behavior associated with that primitive is scattered out throughout my application. So in this case, I have one switch statement I'm working with, one switch expression. But if I look at my code base and I've got 24 different switch expressions dealing with this object, it'd be nice to kind of center all of that behavior around this expiration type object. But in order to do so, we're going to have to bring in a little extra help to transform this expiration type enum into something that's a little bit more behavioral. Now, C# doesn't have the concept of behavioral enums, but folks over the years have built ideas of behavioral enums into basically classes or structs that have enum type properties with all the benefits of having a class. So that's what I'm going to do here, is I'm going to transform this into an enum class. Now, the enum class that I'm going to be using is actually one from Steve Smith called Smart Enum. So this is a package that basically wraps classes in enum-like behavior, so you get kind of the best of both worlds. And so no longer am I going to have an expiration type enum, I'm going to have a smart enum of, bring that in. It's going to be of type int. And expiration type. Let's see, what does this look like? I'm going to go cheat. Oh, there we go. There we go. So a few of the things I need in here. I need a constructor to say, I need to be able to build this up. So let's go ahead and implement the missing members. And one of the things enums need, and kind of the .NET based enums, is the name of the thing and then the value. And so I have to provide that as a constructor to say, here's the name of the thing and here's the value of the thing. What I'm going to do, though, is make this private so that I can only build up the actual public versions of this inside the actual class itself. So I'm going to have a public static read-only expiration type assignment equals new, passing in name of assignment as the name, assignment. And the value is going to be 1. I'm going to do the same thing with fixed, and fixed. Okay, a little bit of C# NIME goodness here. You're having the target type new expression, where I don't have to repeat the name of the type twice. And at this point, my expiration type is like this new smart enum. And then the smart enum does have the ability to do things like expiration type dot. Now it has a bunch of methods like from name, from value, try from name, try. So all the methods you find on enums, it has as part of it as well. But I have to do the switch value expression type dot assignment dot. Oh, I can't do the switches anymore because switches require constant values. I don't have those constants anymore. So I'm kind of in this bind where the switch expression isn't quite working for me anymore. But there's something else I want to do here, which is looking at this code, all of this code actually only deals with the expression type, passing in the offer type as like the thing it needs to calculate from. So what I'd like to do is kind of move the behavior for calculating expiration date based on the different like internal logic of how different expiration types are dealt with, really down to the expiration type or the expiration type object itself. So looking at, for example, like this stuff, this is very specific of calculating expirations to the expiration type object. The only thing it really needs to know about is this days valid. So let's do that. I'm going to extract this into a method. What'll that do? Looks almost exactly the same. So I'm going to just copy this code, because there's not a straightforward, easy way of doing this, and I'm going to move it over to the expiration type object. So public decimal, datetime. Yes, datetime. Calculate expiration. I'm going to pass in an offer type object. Type, and in this case, I can't necessarily do the switch expression, so I can do something like if return switch offer type dot expiration type, and then I can do the same kind of thing before, where I say, well, if it's this kind of expiration type, do this. If it's expiration type, do that. Okay, so I'll need to actually go back to our expiration date equals our date time expiration date, and then return expiration date. And I'm going to need to go back to kind of the switch expression, switch statement that I had earlier. So switch, whatever, whatever, whatever. Now, when I have each of these different methods or the different things that are dealing with these different types of expirations, and have these all over the place of this conditional logic switch expression logic, doing based on this different kind of thing, that's also another code smell. That's known as the kind of conditional complexity code smell, where I've got a lot of conditions that are very looking very similar to another. In the Refactoring to Patterns book, one of the things it describes is the ability to extract each of these different conditions and the work they do into a strategy pattern. And the idea behind a strategy pattern is each of the different kinds of expirations will have all of the methods associated with what is specific to that expiration type inside of it. So instead of me like making the switch expression better, instead of what I like to do is take each of the logic inside of here and move that logic into each type associated with those individual expirations. So the way I'll do this is create types for each expiration. So I'm going to create a private class, assignment expiration. That's going to inherit from expiration type. And it's going to have a constructor, but instead of taking the constructor value, what I can do instead is say, I'm going to take those values that I was assigning up earlier and just put them inside it itself. So it actually encapsulates all of its values as well. And the value is 1. Sign. I've never been able to spell that word right. There we go. And I'm going to do the same thing with fixed expiration. Name of fixed, and its value is 2. Okay, so that got the constructor arguments. The next thing I need is I want to delegate the calculation of the expiration from here into the actual method itself. So what the actual types itself. So what I'll do is change this class to abstract, and they'll have a public abstract date time, calculate expiration. And the logic behind each of these, this assignment-based version, this date time today that add days date valid, is now going to be as part of this method itself. So instead of not implemented exception, date time dot add today's date valid, but which date valid is that? That's offer type dot days valid. And what's the other one? Fixed expiration, same thing. That is going to be this part right here. And instead of these properties on offer type directly, I'm going to have to access it through the proper offer type parameter. Okay, so now I've gotten this, but what about this last one, this last throwaway one, where I say, well, you can't be one of these. One of the things about this, this smart enum is that it disallows any kind of invalid value. So I don't actually have to worry about this last case of does this thing have a value or not. All right, the last piece I need is to get rid of these and say, now I'm going to new up these inner types itself. So new assignment expiration, and this one is, oops, new fixed expiration. Public, and public. Okay. So now all the way back up on my offer type object, this now all goes away. And I say, go ahead and use the expiration type to calculate the expiration, passing in myself. So at this point, from the assign offer handler, the logic of calculating the expiration date is now fully encapsulated inside of the offer type object. And the very last one I wanted to do quickly is this assign offer method. This assign offer method is really all the work of assigning an offer to a member. And so what I can do here is the kind of exact same logic I did before, which is, well, let's just go ahead and move this method over to one of the objects that I'm dealing with. And which object should that be? Well, it kind of looks like that most of it is dealing with the member object itself. So why don't we move all of this, make method non-static, and move this to the member object. And so now I've got the calculation of the expiration date. I've got the assigning of the offer. You could look at this one as well and say, wait a second, this date expiring, I'm already actually calculating that, or I'm already passing the offer type in, so do I need to pass that in again? So I would say, let's go ahead and remove this. Change the signature, remove the date expiring parameter. Now, this part here, which I did have right there, I can now move all the way down to here. Date expiring is offer type to calculate expiration dates. And so now, looking at my handler here, it is much more encapsulated. I've got one little piece, which is calculating the offer value. And so then when I get to my domain model, I'm just passing in the type of offer and the value itself. But otherwise, all of the logic that was really the business logic of assigning the offer, I've now pushed down into this actual member object itself. So where can we go from here? There's still a lot more refactorings we can look at. One of the things you'll see is that this is exposing collections directly with a bunch of public setters. So we can come in later and saying, okay, let's go ahead and make a lot of these private because I've removed all of the setting of these from outside of here. I can remove some of these like public collection objects and encapsulate those collections behind read-only lists or interfaces to not allow anyone to do anything. So as I start pushing my behavior down into my domain model, then what it'll do is allow me to start removing a lot of the public things that I'm exposing to the outside world, because now my domain model has all the methods that are mutating itself. So Here. So that was domain-driven refactoring. If you want to read more about this topic, two great books out there that I recommend are the Refactoring book from Martin Fowler, the Refactoring to Patterns book, which I think is only available on PDF, but it's still a fantastic, correct way to approach design patterns. Otherwise, thank you all very much. You can find the full refactored example on my GitHub, github.com/jbogard presentations. There's a domain-driven refactoring repository there. Otherwise, thank you all very much. I hope you'll have a great evening, afternoon, rest of the day. So thank you very much.
Thank you, Jimmy, so much for your presentation. And thank you so much for waking up this early to do a presentation for us. We appreciate that.